Hello friends, in the last video we have seen theory based on types of energy sources. Now to get the clarity on this, we will start with a problem based on it. You can see a problem on your screen. The VI characteristic of X and Y non-ideal voltage sources for figure A given in figure B, you have to find the value of I. So, first of all, what is meant by non-ideal sources? Non-ideal sources means they are practical sources simply. Meaning, if you say X source, then it should be replaced with plus minus X as a source voltage along with Rx as an internal resistance. Whereas Y should be also replaced with minus plus Y along with series resistance Ry. So we will first of all replace them with their practical voltage sources and then we will start solving the problem. So as I said, X is a voltage source having this positive negative as a polarity. In series to it, it has internal resistance, let's say Rx. Next to it, there was another voltage source minus plus Y. In series with it, it has got its own internal resistance, let's say Ry. And then there is some load connected over here having resistance as 1 ohms through which current I is flowing, and what we need to find is this current I. So I can consider this as loop current I. Now if I apply KVL over here, I can find the value of I. So if I apply KVL over here, let me give the polarity across Rx and Ry like this. So let's apply KVL. Negative to positive, I should consider X. Positive to negative, I should consider minus I times Rx. Negative to positive, I'll consider Y. Positive to negative, I should consider minus I times Ry minus I times 1, I can consider as I, and whole equal to 0. So now I'll take all the terms with value I to right hand side. So I can rewrite this as X plus Y equal to, I'll take I common, so what remains inside is Rx plus Ry plus 1. So I can write I value as X plus Y whole divided by Rx plus Ry plus 1. What they are asking us, the value of this I. I'll get this value of I only when I know the values of X, Y along with Rx plus Ry plus 1. So now the task is to find X, Y along with Rx and Ry values. For this, we need to again check back our problem. In our problem, as you can see, X voltage source is given with a characteristic. If you remember that we have seen the characteristic for practical voltage sources, we will try to plot VI characteristic of X. So for X, they have already provided us a characteristic. This is V and this is I. And for Y also, they have provided us a characteristic like this. They have given 4 volt 2 ampere here, and for Y and for X they have given 4 ampere versus 2 ampere, and for Y they have given 3 volt versus 3 ampere. Please understand, if you have seen the previous video where I have considered this practical voltage source characteristic, it was nothing but the value Vs value. This 4 volt is nothing but the value of Vx. Whereas this is nothing but the value Vy, which is nothing but 3 volt in this case. Now try to understand my point. My point is, if you see this characteristic, you can actually see the value of I equal to 0. If you remember, this was VL versus IL characteristic. When load current is 0, load current can be 0 only when you open circuit the load. So by open circuiting the load, the voltage that you get over here, which is VL, which is nothing but Vx, can also be called as VOC, where VOC stands for open circuit voltage. Similarly, at this point, the current of IL value is 2 ampere when voltage VL equal to 0. Now, when load voltage can be 0, load voltage can be made 0 only after short circuiting the load. In fact, I can call this current as short circuit current, ISC. I repeat my statement, you get this current at VL value equal to 0. When load voltage can be 0, load voltage can be 0 only when you short circuit the load. So this is the value of current only when you short circuit the load. So I can consider this value as ISC. Similarly, I can call for the second characteristic this VY as VOC and this 3 ampere as and ISC. Now you may get wondered for what reason we have calculated this VOC and ISC, because this VOC and ISC are responsible to give you the value of their internal resistances. The internal resistance formula is always open circuit voltage by short circuit current. So since this characteristic is plotted for X, I can say that Rx equal to VOC by ISC, which is in this case 4 volt by 2 ampere, which becomes 2 ohms. So the value of Rx becomes 2 ohms. Whereas for Y characteristic, as you can see, the VOC and ISC is given. So for Y characteristic, VOC was 3 volt and ISC is 3 ampere. So RY comes out to be 1 ohms. So since we have the value of Vx, we have the value of Vy, we have the value of Rx, we have the value of Ry, we can substitute all of them in the previous equation. So the previous equation of I was x plus y upon Rx plus Ry plus 1. This x plus y is nothing but the values of x and y, which is nothing but Vx and Vy. So now I can rewrite this as I equal to, so Vx we have 4 volt, Vy we have 3 volt. So this is 4 volt plus 3 volt divided by Rx is 2, Ry is 1 plus 1. So how much do we get is 7 upon 4. So if you solve this, you'll get 1.75 ampere. So the value of I which they are asking you for is 1.75 ampere. So when they have given you 4 options, out of which 1.75 ampere is an correct option. I hope you have understood this problem. Thank you so much for watching the video. Stay tuned with Ekeeda. Subscribe to Ekeeda.